Yes?
How do you calculate that percentage without using the applet?
The area under the normal curve without using the applet? There's no closed form expression for the area under the normal curve. That's why you need to memorize those three values, the area under the curve between plus or minus 1, plus or minus 2, and plus or minus 3. But I mean, what it is mathematically, we're trying to find, we have this curve that looks like 1 over root 2 pi e to the minus x squared over 2. We want to find the area under this curve between minus 3.71 and plus 0.174. Right? This integral does not have a closed form expression. You just have to evaluate it numerically, and the applet is evaluating it for you numerically. So you need to memorize the numbers between the area under the curve between plus or minus 1, plus or minus 2, and plus or minus 3. Those are the only numbers you'll need to know. Yes? So the question is, why wasn't it 387? Why was it 387 and a half? And it's back to this idea here that for a binomial, let's make this a little bit bigger number. The sort of the bins in the probability histogram that are representing the probabilities. If I wanted to find the probability that this was between 4 and 8, what region would I be looking at the area of? I'd be looking at the area starting at 3.5 in order to capture the whole bin that includes 4. And I would be going up to 8.5 because that's the end of the bin that includes 8. It's the area of the whole bin that includes 8 is the probability that it's 8. For a binomial, the bins are always, they start at a half integer and go to a half integer. In the general case of, if the values of the numbers in the box aren't integers, then it doesn't really make sense to apply this continuity correction. The values in the box are integers, but they're not sort of equally spaced, so the outcomes aren't equally spaced like this. It's kind of a coin toss as to whether it'll end up being a better approximation or a worse approximation if you use the continuity correction. But I'm asking you to sort of do it. If the possible values are integers, then you know that if the possible value of the random variable is only an integer, then if you're asked for the probability that it's at least 2 and no bigger than 7, you should start at 1.5 and go to 7.5. Yes? This is the standard error of a binomial. Okay, so what we just saw numerically is that this is approximately, what was it, 56.9%? Was that what we got? Okay, 56.9%. Okay, and we did this not by doing the integral, but by highlighting the area under the curve, and that did the integral for us numerically. Okay, so the question was, where's this denominator coming from? So if x has a binomial distribution like that, then maybe I should just write it over here. The expected value of x is n times p, and the standard error of x is the square root of n times p times 1 minus p. Right? In this case, n times p, this is 600 times 10/14, and this is the square root of 600 times 10/14 times 4/14. Okay. Yes?
I hate to kind of beat the bush on this, but how would you use the 1, 2, 3 approximately this in order to find the area or the percentage of area under curve? So I'm not quite sure how to
Use the 1, 2, and 3. I'm not following you. I'm sorry.
the area under the normal curve between 1, 2, and 3.
Okay, so that wouldn't solve this problem. Okay, because this problem required you to know the area under the curve between minus 3.7 and plus 0.174. But if this had worked out on an exam, this would work out, so this would be something like the area between minus 2 and plus 1, which you could work out. Yes?
So we would have, like, you would give us random numbers at random, but when we found those changing it, it would end up being
It would end up being a nice integer. Yes. Let's pretend that the range that I asked for ended up giving you, let's say, minus 3 to plus 1. Okay? Then let's just do what you would need to do to turn that by knowing the other two numbers, how that would work. Okay, so what is the area under the normal curve? All right, so what do we know? We know that the area between, so we're looking for, take it back, we're looking for the area between here and here. Right, that's what we're looking for. What do we know? We know that the area between minus 3 and 3 is 0.997. Right, we know the area between minus 1 and 1 is 0.68. We know that the curve is symmetric. Yes? So what's the area? So we're going to divide this area up into two pieces. The area between minus 3 and 0 and the area between 0 and 1. What's the area between minus 3 and 0? If the area between minus 3 and 3 is this, and the curve is symmetric, the area between minus 3 and 0 is going to be half of this. Okay? So this area from there to there is 0.997 over 2. And this area is going to be half of 0.68. So this piece is 0.68 over 2. So if we add those numbers together, that's the area between minus 3 and 1. Okay? Sure. Yes? Yes. So this is, the question is this the same thing as the square root of n times the SD of the box? Yeah, if you remember, for a 0, 1 box, you have a 0, 1 box with a fraction p of tickets labeled 1. Then the average of the box is equal to p. The SD of the box is equal to the square root of p times 1 minus p. Okay, so the square root of n, in this case, the square root of n times the square root of p times 1 minus p is just the square root of n times p times 1 minus p.